Right. Hey, you guys. Let's see who's with us. All right. Good morning, everyone. We are going to start with our homework. Okay, so we're going to go over our homework first. For my Zoom people, go ahead. All right. So with the first homework assignment, remember you had two different homework assignments. One was for 6-1. That was just about justifying statements. This is the homework for that. Our super fancy bird Wi-Fi is moving super quickly. All right, so the first one, number 4, says if angle 2 is supplementary to angle CBE, then angle 2 plus angle CBE equals 180 degrees. How do you know that? Well, definition of supplementary angles. That's the correct answer to that one. Number 5 says if angle 2 is congruent to angle 3, then ray BF bisects that angle. Definition of angle bisector. CB, number 6, CB plus BF equals CF. Little plus little equals big. That is the segment addition postulate. Number 7, if angle DBF is a right angle, then line segment HD is perpendicular to line segment CF. That is definition of perpendicular lines. Number 8, if the measure of 3, angle 3, is equal to the measure of angle 6, then the measure of angle 3 plus the measure of angle 2 equals the measure of angle 6 plus the measure of angle 2. So you can see they're adding that to both sides. So we went from not having the addition to adding. So that is the addition property of equality. Any questions about those? Yes, ma'am. Number 6. Remember, transitive property has to have 3 things. So you would have to have A equals B, B equals C, then A equals C. So this is just one equal sign. So it can't be transitive with just one equal sign. That's just a single statement. That's that postulate with the segment. What else? Okay, now let's go and look at 6-2. This is the one with the proofs. How'd y'all do with that? Good? Horrible? Did y'all buy your homecoming shirts? Molly Watkins came by this morning and said to put her name down if you haven't. They just say like bird football. They're pretty plain. Yeah. They're not good. But they're cheap. I mean, it's only 15 bucks. Okay. Here is the key. Right here. Number 4. You had to fill in the blanks. So the first one is given. All right. So that one's just given. Then after that, it tells you that angle 2 is going to be congruent to angle 3. Well, you know that because of the definition of bisector, of angle bisector. Okay. Then it says, okay, definition of congruent angles. Well, that's talking about the measurements. So they've added the m's. So m angle 2 equals m angle 3. That's the measurements. Then it says angle 1 is complementary to angle 2. Well, that's another given. So that's just given. Then it says angle 1 plus the measure of angle 2 equals 90 degrees because it's complementary, okay? And that is the definition of complementary angles. The definition tells you that it's going to equal 90 degrees. Then it says The measure of 1 plus the measure of 3 equals 90. They did the substitution. They told us up here that they're equal to each other. So since they're equal to each other, we could substitute it in. Then from there, we put our final answer, which is angle 1 is complementary to angle 3. That's because of the definition of complementary angles. Okay. Anybody need to jot that down? You have it in your module if you need to go back to it and look at it, but that's that. Now, did I give you the other page? Whoops. Good. All right, so this is number 9. Number 9 was the one that we were doing. Let's see, where's the proof? There it is. Here's your key for number 9. So the first box was your given. The next box is your segment addition postulate. Then you have your substitution property. You're substituting in that 6. Then you have the subtraction property. Remember, don't get too concerned about that. Don't let it be too heavy on you. I know that it's challenging, but it will get easier the more that we work on it. If you have emailed me within the last, well, like after I left school, from 4 o'clock until now, I have like 14 or 15 emails. I will be answering those next hour, okay? So I'm not ignoring you, but I turn my notifications off because when I get home, it's just crazy town at my house. So I'm going to be answering them 3rd hour on my planning period, okay? All right, so now we are starting a new lesson today. We are going to be on page 73. Page 73, it's all about parallel and perpendicular lines. This lesson is specifically about parallel lines, okay? All right, so 73, let's go there. You can see our learning targets say, make conjectures about the angles formed by parallel lines and the transversal. Prove theorems about these angles. Okay, so we're going to be dealing with parallel lines. What do you already know about parallel lines? They're never going to meet. They don't touch each other. Why? They have the same slope, okay? Parallel lines have the same slope. They're traveling at the same rate of change. They are not going to intersect. So that's what we know about parallel lines. Now, the first part of this lesson is, it's trying to make it realistic. So let's just go through it, but we'll probably go through it pretty quick. Matt works for a company called Patios by Madeline. A new customer asked him to design a patio and walkway. The rows of bricks in the patio will be parallel to the walkway, as shown in the diagram. So far, Matt has used stakes to tie down two parallel strings that he can use to align rows of bricks. He has also used paint to mark the underground gas line to the house so that he can avoid accidents during construction. The string lines and the gas lines intersect to form 8 angles. All right. So, it's not really important what he's doing. What's important, though, is that what we're looking at are parallel lines. You can see you've got these parallel lines right here. And then you have this gas line, which you're about to learn is a transversal, and it's creating 8 angles. Okay? So looking at this, you can see the 8 pairs of angles. Okay? Everybody okay with that? Flip the page. Now, I'll keep mine pulled up so that you can see. I'm going to give you some of these, and I want you to figure out the other ones. if I tell you that angle 1, because it says use a protractor, we're not getting the protractors out, but if I tell you that angle 1 is 115, what's angle 3? What is it? And why is it 115? Because they are touching noses. What type of angles are those that touch noses? Vertical. They are vertical angles. Now, you tell me what angle 2 and angle 4 are. And how do you know it's 65? They're supplementary. Okay, so that means they have to equal 180. Now, what's 5 going to be? How do you know it's going to be 115? That's exactly right. It's parallel lines. So that means that whatever is here has to be exactly the same. They're like a carbon copy of one another because they're parallel lines. Okay? Now, number 2 says the gas line is a transversal. We'll use that word a lot this year, transversal, of the string lines. Name an angle pair formed by these lines that match each description. 4 pairs of corresponding angles. Corresponding angles is defined over in the math terms. So if you look at what it's defined as, it says corresponding angles are pairs of non-adjacent. What's non-adjacent mean? What's adjacent mean? They're next to each other, like your adjacent neighbors share that grass. So non-adjacent means that they don't share that ray, okay? Non-adjacent. So we need non-adjacent angles such that the angles are on the same side of the transversal and one angle is outside the 2 lines and one angle is between the 2 lines. Yeah, corresponding angles. So they cannot be touching sides. So they're not going to share this same side. That would make them adjacent. So they're non-adjacent. Let me give you an example. It's going to be a little bit easier if I give you some examples. So what number are we doing? This is 2A. So one example is angle 1 and angle 5. Those are corresponding because they're not adjacent, but they are exactly the same measurement. They're also in the same location. They are your top left angle, 1 and 5. So you give me the other 3 sets. There are 3 more sets. You list those out. Who corresponds to angle 2? Angle 6, because it is the top right. Top right. Okay. Who corresponds with angle 7? Good. Those are the bottom left. And who corresponds with angle 8? 3. Everybody understand corresponding angles? Same spot, just on the different set of angles. Okay, we've got a 4 set here and a 4 set here. They're same spot, just in the different location. Okay, now the next thing that we're going to talk about is same side interior angles. Well, that name gives it away. Same side means that they're going to be literally same side, okay, of the transversal. And interior means that they're going to be on the inside of the parallel lines, okay? So if I'm looking at my transversal and I'm staying on the same side and I'm going to stay on the left, who are going to be my same side interior angles? 4 and 5. They're on the same side. They're on the inside. So that's what? 2B. So angle 4 and angle 5. And also who? Angle 3 and angle 6. Those are the ones on the other side. Same side interior means they're on the same side of the transversal inside the parallel lines. Okay? Alternate interior angles. What does that mean? Well, that means they're going to be on opposite sides of your transversal, alternate opposite sides, but it's still going to be interior, okay? Good, and it's not the one that's right beside it, okay? Because I think it still says non-adjacent. If it says alternate interior angles are pairs of angles that are between the two lines and on opposite sides of the transversal. So 4 is going to be with 6. Okay, so this is what, 2C? 4 and 6 are alternate interior angles. What's the other set? 3 and 5. So those vocabulary words are what we're going to be using a lot, and we'll use those to use proofs. We'll say, you know, alternate interior angles. Don't they have the same degree? Wasn't this one, was that 65? Angle 4 was 65, and so is angle 6, right? So they're congruent. We're going to be talking about that as we keep learning. So you're going to learn a lot about these, but that's how you identify who we are discussing. Okay, so look with me at number 3. And let me go to that. All right, number 3. Based on your answers in item 1 and 2, make a conjecture about each type of angles pairs formed by parallel lines in a transversal. What do you know about corresponding angles? They're going to have what in common? Okay. Same side. But also what? Same measure, right? They're going to have the same measurement. Okay. Which means if they have the same measurement, they are congruent. They are going to be congruent. The same measurement means that they are going to be congruent. Now, same side interior. What do you notice about those two? Are those the same degrees? They add up to 180. Okay, so add to 180. What do we call that? That's right. Okay, so your same side interior are going to add up to 180, which means they are supplementary. All right, C, alternate interior angles. What did we notice about those? Same measurement. So since they measure the same thing, what are they? They are congruent. All right, page 75. The two lines below are parallel. Again, never assume that. Don't ever assume that lines are parallel. They must tell you, okay? So it says the two lines below are parallel. Draw a transversal to the parallel lines, okay? Your transversal can be your transversal. Use a straight edge so it's not sloppy, but draw a transversal. Number the angles formed above and record the measure of each angle. Just number them. There's no fancy way that you have to do it. Now, We're not going to measure them. We're not going to get out our protractors to do that, but it's going to be the same thing that you noticed last time. You don't have to write this, but if mine here is like, let's say 110, then what would this one be? And this one would be 70 and 110. So it's going to be the same thing. They're wanting you to see that it's going to be exactly the same thing as the last time, because it's going to be that way every single time. If you have parallel lines and you cut it with a transversal, you're creating a pair here and a pair here that are going to be exactly the same. Okay, so just know that. There's nothing else you need to do there other than draw the transversal and put 1 through 8. And your 1 through 8 doesn't have to look like mine. Like some students will do like 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter. Okay, it just has to be a number so that you can identify that angle. So when I look at your paper and you say number 8, I know exactly who you're talking about. Okay, all right. So number 5. Do the answers on number 4 confirm the conjecture you made in item 3? Well, what did we say in item 3? That they're all going to be congruent and supplementary. So we didn't actually finish this one, but yes, that is going to be true every single time. So for number 5, you can say yes. Corresponding angles will always be congruent. Okay, corresponding angles will always be congruent. Same side interior are always supplementary, and alternate interior are always congruent. I'm going to just add alternate interior and corresponding angles are always congruent. So that takes care of both of those. And then we also need to say same side interior are always supplementary. So you're just stating that. So now we know that that is a proof. We can use that. We have seen it twice, which we didn't actually, but we're pretending that we saw it twice. And so we know now that that is always going to be the case. Corresponding angles, always the same. Alternate interior angles, always the same. Same side interior are always going to be supplementary. Okay? All right. Moving to page 76. Okay? 76 says the corresponding angles postulate. This is important because what do we do with postulates? We use those as justification statements. Okay, so this is a postulate, which means it's something that we eventually are going to be able to use. It says the corresponding angle postulate involves angles formed by 2 parallel lines cut by a transversal. Based on your earlier conjecture, write down the corresponding angles postulate in an if-then form. All right, so here we go. If 2 parallel lines are cut by a transversal, if 2 parallel lines are cut by a transversal, then what are we talking about? Corresponding. What do you know about corresponding angles? What will corresponding angles be? If 2 parallel lines are cut by a transversal, corresponding angles will be congruent. Everyone, give yourself a pat on the back. Congruent. Always. So now you can use that, and you can use that postulate in a proof, okay? So if two parallel lines are cut by a transversal, then corresponding angles will be congruent. Do you need to prove this postulate is true before you can use it for a proof? Do we need to use that? Do we have to prove that? No. Okay. No, we don't. It is accepted as true. Postulates equals truth. So there's no reason to prove that because it is a postulate. So you can just write that down as a reason. Number 7, the alternate interior angle theorem. What did we learn about alternate interior angles? They are, nope, that's same side. Congruent. Okay, so those are congruent. Same side interior angles theorem is going to be, those are the ones, oh wait, those are on the same side. Those are supplementary. Okay, so based on your conjecture earlier, we want to write an if-then statement for the alternate interior angles. So if two parallel lines are cut by a transversal, then the alternate interior angles are, what did we say they're going to be? Congruent. Hopefully you can read my sloppy handwriting. All right, then B, I'm going to do that one up here. It's the same thing. If two parallel lines are cut by a transversal, then the, what are we talking about? Same side interior. Same side interior angles are not congruent, but that's right. So you just wrote out and created 3 postulates that now we can use to prove things. How do you feel about yourself? Feel good? Awesome. All right. Let's look at check your understanding. In the diagram, L, line, M. What does L, line, M? What's that mean? That's parallel. This symbol right here is the symbol for parallel. So if you didn't know that, write that down so that now you know that. It's part of what you know. So L is parallel to M. Use a diagram for 1 through 8. Number 8, explain how you know that angle 4 and angle 3 are same side interior angles. How do you know that 4 and 6 are same side interior angles? Same side of what? Same side of the transversal. And inside who? That's right, the parallel lines. Number 9. Are 2 and 3 corresponding angles? No. They're adjacent. Remember, it has to be non-adjacent. So, no, they are adjacent. Number 10, if the measure of angle 5 is 65, what's the measure of angle 4? And how do you know? It's 65 degrees, which is correct, but how do you know? They're what? What are 5 and 4? That's right, alternate interior angles. So you know that those are alternate interior angles, which means they're going to be congruent. So that is correct. All right. Number 11, angle BCD and angle CGE are corresponding angles formed by 2 parallel lines cut by transversal. Given that angle, or the measure of angle BCD equals 3x plus 6, and the measure of CGE equals x plus 24, what is the following? So corresponding, what do you know about corresponding angles? They're congruent. So what can we do with this algebra? You can set them equal to each other. So then we've got 3x plus 6 equals x plus 24, because we know corresponding angles are congruent. So since we know that angle BCD is going to be congruent to angle CGE, you can set them equal to each other and solve. So I'm going to solve quickly. Did you get x equals 9 if you beat me? Okay, so x equals 9. Then what does that make the measure of BCD? Just plug in. What's 3 times 9? 27 plus 6? 31 degrees, right? 33? Thank you. Leave it to the math teacher to mess up the math. Okay, explain how you found your answers. Well, your work does your explanation for you, but you would just say that corresponding are not equals, are congruent. Okay, I've been rushing because I want us to stop right here, because I want you to be able to do your homework so you don't have homework on a game night. Okay, so that's what I've been trying to get through this lesson so quickly. We will come back and we will finish up that proof. We will come back to number 12 eventually and then finish that up, but I want us to hit a stop so you guys can work on your homework. So if you look on page 78, okay, 78 is our new description for you. You are going to determine whether each statement is true or false. So literally all you need to do is tell me if it's true or false. And then it says justify your reason with an appropriate postulate or theorem. Okay, so if it's true, how is it true? What postulate represents that? Okay, now if it's false, would you give me a postulate? No. Or you could say that this postulate proves it false if you wanted to. But that's what I'm wanting from you. I want you to do numbers 5 through, let me read 20. Yeah, 5 through 20. Y'all do that. You've got like 20 minutes. So 15. Sorry, y'all. Crazy. 15 through 20. Get that done. Get that submitted. And then you don't have to worry about math tonight. Okay? Deal. Miss Cole, you're the best. I know. Anybody online have questions? About to log off if y'all don't have any questions. So if you do, unmute yourself. Which one are you saying is false? Yeah. And it gives a reason why it's false. It just says blank, blank, blank theorem proves that it's false. So just show me what is going to prove it to be false. All right, guys, if y'all don't have any questions, I'm going to log off of here. Y'all have a great rest of the day. Good weekend. Make sure you get on tomorrow and do your work. I will see y'all later.